As Llewellyn just told you, I'm an ex-employee of the CSIR. I'm now retired since the beginning of this year, and I'm a professional architect, so I'll find stuff to do at home. But whilst I was at the CSIR, my main focus was on sustainable materials. I always hate to use the word green. And so my presentation, the task that Llewellyn gave me, I've turned it into a question. What is sustainable material resource use? Obviously in the context of South Africa. I will first take you through an introduction to look at what is happening to materials generally and in construction. We will look at the measuring approaches, and I've got a couple of case studies. I do a very brief situational analysis, and then I have a conclusion. The global status of materials use has not looked very good. Materials experts know it. From the standpoint that is like since the 19th century, I mean, since the 20th century, since like the year 1900 up till now, that's where I'm counting from. It has really been a very chaotic growth. The unprecedented production and consumption is exacerbated by the conventional economic model, which is used internationally by all nations. It's actually an inheritance from the Industrial Revolution, and it's remained like that. As you can see from my diagram, it's open-ended. Our manufacturers, product manufacturers, take materials from out of the ground, manufacture, we use, and at the end of life, when nobody wants it anymore, disposal by landfill, and off we go to dig up more materials. And that's the reason why we are using up our supplies so quickly. The picture there tells a story, and that is at 2016, how we are doing in terms of resource use. It is quite scary. The summary is that we will eventually need 1.6 worlds, but obviously that is impossible. We need to try to live within the carrying capacity. So it is quite a serious matter. In terms of the sector, the conventional buildings consume about 50% of all raw materials extracted annually. And as we go into low energy buildings, which are also known as near zero energy building, that is my abbreviation there, the NZ, that's what it means. We are requiring more materials because the building envelope requires more materials. So the word zero would tend to deceive us because we get the impression that we are done, but we are only done from the point of view of the use phase operational energy. Materials then start to dominate the life cycle, and their embodied energy, toxic effects, and so on, then take over the environmental impacts. And therefore, as we mainstream low energy buildings in South Africa and elsewhere around the world, it's becoming even more critical, that we should address the issue of efficient use of not just building materials, but of all materials. Some of the consequences that I've pointed out already on my previous slide is that we are exceeding our planetary boundaries, and we have big issues of massive biodiversity loss. And we should bear in mind that ecosystems support us, Without them, we are nothing. So it is indeed a very serious matter. Here I try to define, in my mind, what I believe sustainable material resource use should mean. And it is that material production and consumption patterns should meet our present needs without jeopardizing the material resource needs of future generations. As you may have noticed from one of my previous slides, between 1960 and 1995, world population increased 1.8 times, and by contrast, main materials production increased more than twofold, and synthetics increased almost 6 times. So yes, it is. I can't repeat it often enough. It is a very serious matter. Measuring material resource use. From the beginning, just post release of the Brundtland report, we started bandying about various definitions, words such as green and sustainable. And the green approach has very much taken root internationally, and it goes along with the open loop economic model. Green tends to measure improvements against existing products. For example, in the Green Star rating tool, we are comparing the green rating or the green building against a conventional building. So that's what I mean there. Green also tends to analyze only a portion of the system, and thus we would talk a lot about operational energy efficiency and declare that it is zero, but we are silent on what is happening in other parts of the building supply chain, which could be even worse than impacts due to energy use. Green also focuses on qualitative results. By contrast, the sustainable approach is actually concerned with what is happening with Mother Nature, on which we depend for life. We are looking at the flows from and to nature, and we are trying to close that open loop, and therefore we analyze the entire system to find out what is going wrong in which part of the system. We identify what we call the hotspots, that which causes the most impact, and we use quantitative means in the analysis. On this slide, I go further into the sustainable approach, and internationally there are 2 types which are being used. Type 1 they call eco-efficiency, also known as doing more for less. And the principles are essentially that of dematerialization, which means extreme resource productivity. The first statement about it was at Carnul's in 1994, and the people who put together the initiative called for a factor 10, meaning that we actually have to reduce resource, we actually have to improve resource productivity by 90% in order to achieve a factor of 10 improvement. The rationale is that if we only look at the input side, if we reduce how much material we are withdrawing from nature, then surely the impacts due to materials use, such as contributions to climate change and so on, would be reduced. However, in order for this approach to be effective, all players in the value chain have to play their part. All actors in the value chain need to play their part. Designers, what I mean by plan the funeral at birth, is that if you take a building like what we are in now, it may be rated as green, but it's put together such that the chemicals are used and it all holds together, so you can't easily pull it apart. But when you get to the point where you are planning the funeral at birth, then you are looking at the possibility of putting buildings or any other products for that matter together as you would put a Lego toy together, so that when you don't want it anymore, you can pull it apart. You can easily disassemble it. So that is the whole idea behind planned funeral at birth. Examples are environmental life cycle assessment, which is also often called simply LCA, and life cycle costing. Those are the tools that are mainly used. And then in the type 2, we are talking about eco-effectiveness, of which cradle-to-cradle certification is the most familiar approach. The whole idea is to close the materials loop by using natural system functioning as a basis for your product design. The rationale is that we close the loop by using waste from no longer wanted products as food or resources to create new products. Again, a value chain action is needed. Our manufacturers need to give us toxin-free materials. Thus, materials such as PVC and so on would need to be taken out. Designers would have to classify their buildings or their products into two types, biological or technical, because it is, research was done and it is clear that natural systems cannot easily absorb technical materials, and therefore it is necessary to make that separation. And as I have indicated there, examples of the tools in use are the natural step and the cradle-to-cradle certification. After that, I then looked at case studies to see how sustainability, these material resource principles are being applied in practice. And this is about the Chinese circular economy. The EU has also initiated a circular economy from a few years ago, but the Chinese one is older, and well, I chose to use it as my case study. And as I have shown there on the left, there's the traditional waste hierarchy that we are all used to. And the whole idea is that they turn it on its head, so that at the bottom, most of very little material would end up in landfill. And the way they do it is by incorporating the 3R principle into a legislative framework. By reducing, they mean that they will design products differently so that they can be disassembled or they are light-weighted. There's a very wide range of possibilities for reducing waste. So they apply them. Reuse means that at the end of the life cycle, they would apply a very important approach called extended producer responsibility, EPR, which involves the manufacturer taking responsibility for post-consumer waste, very importantly. So for example, if you no longer want a microwave, you don't throw it away, you return it to the manufacturer, and the manufacturer will then decide how they will handle it by repairing or remanufacturing to get the majority of materials in that microwave back onto the market. Recycling, obviously all of us are very familiar with recycling. My second case study is more closer to home, the building sector resource efficiency roadmap of the European Union, which they initiated around about 2011. The problem that they faced there is that about 50% of the extracted materials in the EU go into buildings, and at the same time, the sector is responsible for about 30% of solid waste. But at the same time, they have been focusing more on energy efficiency. And so the idea behind the roadmap was to garner action and to say that existing regulations, such as the Eco-Labeling Directive, Green Public Procurement, Waste Framework, and so on, should start to be used so that greater materials efficiency could be achieved. And there again, you see that they are talking about the 3R principle. They are talking about EPR, just as in the Chinese circular economy. And they also make use of the construction product regulation, which is very important because it calls for elimination of toxic materials and so on from the material supplies. They also intend to roll out additional measures, which include environmental taxes, construction and demolition waste, I beg your pardon. That's what CDW is. And they're also looking into standards for secondary materials, which is very important. Then a very brief, very high-level situational analysis. In the South African building sector, we are generally prioritizing energy efficiency over material resource efficiency. The green building movement more or less started about a decade ago, and energy issues have been very, very prominent. If you look at national initiatives over the 10 years, you can see that from the national perspective, there's a drive always to deal with energy issues. For example, the LTMS, which is the long-term mitigation scenarios, which was done in 2007, focused on energy. Similarly, the National Energy Efficiency Strategy, 2008, the same. And more recently, the National Climate Change Response Policy is also concerned with energy and greenhouse gas emissions. Within the sector, predominantly energy focus, but I must say that in recent years, there's more and more emphasis on dealing with material resource issues within Green Star, within the annual Green Building Conferences and Sustainability Week, and that's why I'm standing here speaking, and then within publications in the Green Building Handbook. But some of the major challenges that we do face is that there are some contradictions. For example, the National Waste Act makes provision for sustainable material measures. I haven't captured them all, but surprisingly, we've got extended producer responsibility, we've got eco-labeling, we've got all sorts of measures there. But then you note that national initiatives which cover buildings are then only interested in energy and not materials. And then also the other major challenge is that we are predominantly relying on green material measures. And in a previous slide, I have spoken about the difference between the green material measures and the sustainable measures. And so, in conclusion, I find that the essential requirements for sustainable material resource use in the South African building sector is that we must have mandatory legislation. Well, we've already got the Waste Act, and I'm sure a few other necessary regulations could be put in place. In terms of voluntary requirements, importantly, we would need something that rivals SANS 204, which is focusing on materials. And then, very importantly, the foundation of our measurement should be sustainable and not green. And even more importantly, we would need a value chain action. Everybody in the supply chain, from those who extract materials all the way to consumers, must be involved in some way, because that is actually the only way to resolve sustainable issues in a comprehensive manner. Thank you.